So we want to welcome everybody again to tonight's webinar. I'm Joe Deli Carpini, the Science and Operations Officer, and with me is Frank Nocera, one of our lead meteorologists. And we're going to tag team a little bit, starting off with the July 27th presentation, and then I'll start with that, and Frank will come through with our look at Hurricane Bob 30 years ago and talk a little bit about some of the forecasting challenges that occurred back then. And then we'll take a look at Tropical Storm Henri to kind of wrap up our evening. So to start with July 27th, this was a line of storms that produced widespread wind damage in southern New England. And the timing, interestingly enough, the high resolution models that we often show, they did a very good job showing the storm type and kind of the progression of the storms. But the timing was about 2 to 3 hours too slow. That's a typical bias of our high resolution models. Once the storms get going, they tend to accelerate a little bit quicker than what the models show. And in this case, there wasn't a lot of instability. That's listed by that cape, and we'll show that. But there was a lot of shear, a lot of directional shear, so change of wind direction with height. And that was high enough to really overcome that instability. If you've been with us before, we've told you that the instability and shear can kind of trade off on one another. So if you have a lot of instability, you don't always need a lot of shear. And if you have low instability, you can sometimes get away with stronger shear. So this is certainly a case of the latter. So just to kind of refresh everybody's memory, here's a radar loop from about 4 to 8 p.m., so only about a 4-hour event, but you can see a line of storms dropped southeast across Massachusetts, Connecticut, and Rhode Island. The yellow boxes are severe thunderstorm warnings, and when it gets close to the coast, the blue boxes are special marine warnings for the coastal waters. So quick moving line of storms produced quite a bit of wind damage across the area. So here's a look at some of the reports that we had. You can see quite a concentration of reports here in the Northeast from central New York into New England here, and just some examples there on the left of some of the reports that we had. Trees down in several areas, including in downtown Boston, also across Connecticut and Rhode Island, a bunch of trees down. So, you know, this is probably what Frank and I would call our typical severe weather event in southern New England. So there were a number of power outages, not too many by severe weather standards, but a little over 11,000. And you can see where that's concentrated primarily out in western Massachusetts and more sporadic across the rest of the state. Some of the damage pictures, this is from Jana Brown. This is in Amherst. Our friend Hayden had some damage at his place in Westboro, 50 to 60 miles per hour, and a large limb down. Also in Westboro, some trees down on wires on Main Street. That was from, I guess, an earlier storm. And in Cambridge, large trees took down power lines before falling on a home. Burrillville, Rhode Island, a tree was down on a car near Victory Highway. So let's take a look at kind of what happened. This was kind of the model setup, and we look at this what's called the SREF, or the Short Range Ensemble Forecast, and this is what we can look at a couple of days into the future to kind of get, you know, an idea of what the pattern is like. It doesn't always give you the exact answer, but kind of tells us the ballpark that we're in, and wasn't showing a very high probability of severe weather. As you can see, the shaded areas are areas that are more favored, but there was a low area here from central New York into kind of central New England. But again, when we don't have a lot of instability, the models tend to underestimate the thunderstorms, and you'll see that in some of our other slides here. This is our forecast from our 3-kilometer NAM. It's a high-resolution model, and you can see this is a forecast for 8 p.m., and by 8 p.m., when I showed you on the radar loop, it was already offshore. So this is about 4 hours too slow. 3 to 4 hours, but clearly indicating you have a very widespread line of thunderstorms with wind damage being the main threat. And as we mentioned, it's pretty common for these lines of storms to arrive much earlier than the guidance indicates. You get what are called cold pools, which come out, kind of push the line along, and that's the cooling air from the rainfall in the storm, and that will actually help the storms accelerate as they move toward our area. So usually it's got the right idea, but just a little bit too slow. And you can see here some other high-res models. Might be a little hard to see, but these are some of the other models, and just showing essentially what they were forecasting. All had the right idea, again, showing one form or another kind of lines or clusters of storms. But what we often find out is they don't look that impressive when you have low instability and very strong, what we call dynamics or strong shear in this case. So, you can see clusters of showers and thunderstorms, but, maybe nothing that's going to really draw your attention to say it's going to be a big severe event. One thing we look at is called updraft helicity, and what that is that's just kind of the spin that's in the updrafts, and it serves pretty much as a good comparison for where the severe weather reports will be. So you can see in this case it did a pretty good job, and this was the run the day before. So it's showing a good corridor from Buffalo down across the Mass Pike region toward Boston, which is where the reports mostly ended up, maybe a little bit to the south, but it's usually a good approximation of where your severe weather reports will be. And just looking at the max updraft, this is from the same HREF, showing a similar pattern. Again, probably higher numbers out in the west toward Buffalo, where there's probably a little bit more instability, to a lesser extent here in southern New England. But again, it's just not having enough instability in the model that kind of doesn't make things jump off the charts. And something else you can look at is the maximum 10-meter wind, so roughly 30 feet off the ground. And notice there's pockets in this blue shading of 40 to 50 knots, which is roughly 45 to almost 60 miles per hour. So this, again, correctly highlighted the area that experienced severe weather. Another high-res model, the WRF, this is a 5-kilometer model, but does show the same thing, a progression of 40 to 50 mile per hour gusts moving across the area. Again, the timing is late. This is at 6 p.m. and on the right is about 9 p.m. So it was a little bit slow, but again, showed the potential for a pretty band of strong, winds, 40, 50 knots or 40, 50 miles per hour moving across the entire region and making it all the way to the coast. So we'll take a look. Let's look at a forecast sounding. And for those who aren't familiar, this is kind of looking up in the atmosphere. So height is up here on the left, and temperatures are here on the bottom. So the warmer temperatures are to the right, the colder temperatures to the left. And what we look at in the red, this is the temperature curve going up. It's decreasing. And the green is the dew point. So when they're close together, you have moisture. When they're farther apart, it's dry. We can also look at the wind profile. And this is the one thing I want to draw your attention to. You've got pretty good directional turning or directional shear. So you've got southeast winds to start, turning to southwest and west, and really increasing in speed. The more little lines on here means the stronger wind speed. So you're starting at about 10, 15 knots and rapidly increasing to about 45 to 50 knots, even 50 knots here with the flag. So it's showing a lot of directional shear, and the area between the red and the blue shows us our instability. So there's plenty of cape or instability, and pretty favorable for severe thunderstorms. So the only question was, could we keep that instability, at least enough of it, going all the way to the coast to let these storms survive? But you can see there's actually enough low-level turning, and you can see here, this is called a hodograph, so it kind of plots the wind direction with height. And when you see this low-level turning like this, it's almost that umbrella shape. That's very favorable for tornadoes. And in fact, looking at some of the past events, it was showing the potential for a tornado, even maybe an EF1 or EF2, a low probability of that. So we didn't have any tornadoes form that night, but the environment was certainly ripe if we could have gotten a few storms to kind of split off from the line. So from our messaging standpoint, SPC had a slight risk for the corridor that we were looking at from Buffalo essentially to Boston, and that worked out pretty well. So we messaged really the greatest hazard were damaging wind gusts, and that worked out pretty well. Then later that day, we had a severe thunderstorm watch, which was issued for pretty much that whole corridor. That was in coordination with the Storm Prediction Center and our friends over in Albany. And that seemed to work out pretty well, too. It was a pretty well forecast event. So finishing up with some of the mesoanalysis, kind of what happened. Again, I mentioned there was a lot of directional shear, and you can see that here on this map. This is at about 4 p.m. on Tuesday. You can see values of 45, 50 knots, which are very high for this time of year across southern New England, and that really helps increase our confidence that any storms forming out in eastern New York are going to make it all the way to the coast, even with the lack of instability, which I'll show here next. You can see this is our CAPE or instability, so the higher numbers mean greater instability, and you can see there's a pretty good corridor here from eastern PA across southeast New York into southern New England. So plenty of instability is available. This is about 4 p.m. You can see the blue shading. This is called inhibition, and this is areas that we can't really tap into the instability down at the surface. But if you can get enough dynamics or enough shear to help the storm survive, they still can feed off this instability. It'll just kind of be aloft, and you won't get the strong winds mixing down to the surface. So that was certainly one concern that afternoon. Now, something we call D-Cape, which is called downdraft cape or downdraft instability, it indicates the potential for damaging straight line winds. And again, the higher numbers are more supportive of that. And you can see at 4 p.m., pretty supportive along and just south of the Mass Pike in particular. So this assumes it's conditional on having storms. So if you have thunderstorms, they're able to feed off on this downdraft cape. And that's certainly what happened along the Mass Pike. And just going forward, this is at 6 p.m. showing our instability. You notice it's decreased quite a bit. That's typical as we approach sunset. But you can see there's still a little bit left over, but now a lot more of this blue or this inhibition. But we had enough of the effective bulk shear that allowed the complex of storms to maintain themselves even through the coast. So just to summarize, we had a line of severe thunderstorms that produced widespread wind damage. The timing of the high-res models was about 2 to 3 hours too slow, but definitely showed the storm evolution and threats very well. And it was the effective shear that was high enough to overcome the less than ideal instability, which brought the convection or the storms all the way to the coast. And for the future, the high-resolution models can sometimes underestimate the potency of low-topped, what are called linear convection or linear storms, so lines of storms. And that's true when you have cases like this with limited instability and strong dynamics. So you won't see a lot in the radar simulation, but it's often underestimated in that case. So from there, we're going to wrap that up quickly, and I'm going to pass it over to Frank, who's going to talk about the 30th anniversary of Hurricane Bob. So Frank, go right ahead.
All right, thanks, Joe, and great job on that convective presentation. So good evening, everyone. And yeah, it's hard to believe 30 years ago today, exactly to the day, August 19th, 1991, Hurricane Bob made landfall in Block Island and then a secondary landfall in Newport, Rhode Island at 2 p.m. So yeah, just amazing. That was our last significant major landfalling hurricane for Rhode Island or Massachusetts. It's amazing, we've gone 30 years without having a landfalling hurricane here in Rhode Island or Massachusetts. And maybe that streak will be broken this Sunday with Henri, but we'll just have to wait and see. So wind impacts with Hurricane Bob. It was a Category 2 in a main landfall at Block Island and Newport, sustained winds 96 to 110 miles per hour. And as you would guess, wind speeds of that magnitude, you can have quite a bit of wind damage. And you can see the two pictures on the right here, Falmouth and Martha's Vineyard, lots of tree damage, lots of power outages. And the graphic on the left is an analysis of the observed winds for the event. You can see the highest winds in the dark reds there in southeast Massachusetts, also Martha's Vineyard. And those are 65 to 75 knots of wind. So yeah, the strong winds were confined to that area. But there was also some wind damage with those stronger rain bands that were well out in advance of Hurricane Bob. So there was wind damage outside of southeast Massachusetts as well. So one thing, the takeaway, I think, from hurricanes over the years is that what we try to educate the public on is not just focus on the track of the eye and the strong winds in the eye wall. Really, tropical storm force winds extend well out advance of the eye wall. And this time of year, August, summer, trees are fully leaved. You don't need hurricane force winds to have tree damage. With fully leaved trees, 40, 50 mile per hour winds is sufficient to take down large limbs and have power outages. And that was the case here with Hurricane Bob. Trees were taken down on the weaker side of the hurricane, sustained winds 40 and gusts to 60 miles per hour. And then there's the traffic component. You'll see in later slides that there wasn't a lot of notice. There wasn't a lot of lead time with Hurricane Bob. Wasn't really a well-predicted hurricane, especially by today's standards. But there was a lot of traffic. People waited to the last minute to leave there, where places were evacuated along the coast. So big traffic jams. And actually even the following hurricane in 1996, Eduardo, that actually had one of the largest traffic jams too. That was a 29-mile car back up there from the Orleans Rotary on the Outer Cape to the Sagamore and Bourne Bridge. So between Hurricane Bob and Hurricane Eduardo, the Cape Cod Traffic Management Plan was developed. Unfortunately, since then, we really haven't had a robust hurricane to test those plans, but it's just a matter of time. Heavy rain occurred with Hurricane Bob. There was a band of 6 to 7 inches of rain to the west of the track. And this is pretty typical for hurricanes that come up to this latitude. Normally, when they get up to southern New England, they start interacting with the jet stream, and there's usually a strong frontal boundary as well. And that kind of focuses the heavy precip to the west of the track. And that was the case here in Hurricane Bob. Fortunately, leading up to the hurricane, we had a very dry month of August, and I believe even part of July. So the 6 to 7 inches of rain did cause flooding, but it was more or less minor flooding, where it could have been much worse if we had wet conditions leading up to it, but that wasn't the case. Storm surge was significant. Bob actually took the kind of the classic, almost worst case track for the Buzzard Bay communities there, with a track going from southwest to northeast, from Block Island to Newport. The trajectory was almost the ideal fetch into Buzzards Bay. And they had storm surge there. You could see on those numbers there, up to 9 feet in the upper reaches of Buzzards Bay. So you'll see in later slides the damage and the storm surge from Bob. And I think on the next slide here we have the tide gauge from Woods Hole, and you could see the top of the curve here, the red peak. That was about a little bit over 7.5 feet was the total water level. Now the dashed line on the bottom is what the astronomical tide is. So if there was no surge and no hurricane, that's what the tide would be, and it was about 1.5 feet. And then the total water level was 7.5. So you're looking at about a 6-foot surge there at Woods Hole, which is very impressive. So again, between 5 and 9 feet was the storm surge in Buzzards Bay, and that's where most of the significant storm surge took place, and inundation and coastal flooding. Now here's a before and after picture. I'm not sure exact on the location, Joe. I'm not sure if you know where this picture was taken. I'm going to guess it was somewhere around Falmouth.
Yeah, I think that's correct, Frank.
Yeah, so you could see pretty significant coastal flooding here, storm surge before and after. And yeah, Narragansett Bay was impacted, as well as Nantucket Sound, but really Buzzards Bay took the brunt of Hurricane Bob, basically because of that track lining up with Buzzards Bay. And the storm surge did arrive on the incoming tide. It wasn't quite at the time of high tide. It was almost like mid-tide, halfway between low tide and high tide. If it had occurred at high tide, it would have been even much worse. And that's what makes storm surge and coastal flooding so tough here in the Northeast, or really anywhere, is that the time of low tide and high tide is only a 6-hour time difference between low tide and high tide. So, if the hurricane arrives 3 hours later, 3 hours earlier, and it doesn't occur at high tide, the impacts will be much less. So that's what makes storm surge forecasting so difficult, so time sensitive. And here's a location in Falmouth, a section of Falmouth that had some really significant coastal flooding. You can see the before and after picture there, and not surprising given the location with Vineyard Sound there, just kind of the water funneling through Vineyard Sound right up into the Falmouth area. And the image here on the right, Mattapoisett, that's the upper part of Buzzards Bay, and that really took the brunt of Hurricane Bob. That really had the most significant storm surge, and you can see these homes just pushed right off their foundation. So again, Buzzards Bay really took the brunt of this. So Hurricane Bob forecast operations, and it's pretty interesting when you look back, and given we have a hurricane approaching the area this weekend, and you look at the difference, 30 years later, 30 years ago, it's quite interesting. There was really limited preparation time for this hurricane, and the satellite imagery there on the right, that's 4 p.m. on Sunday. I mean, that's you have a well-defined eye there, and it's only about 24 hours away from hitting southern New England. And again, kind of hard to believe that the build-up, the lead-up to this wasn't really as great as you would think. The other challenges, there were several challenges here. It was peak vacation time, for even us at the Weather Service. pretty thinly staffed. It was kind of hard to staff up for this, and the meteorologist in charge was working the Sunday forecast shift. So it was really a scramble to get extra staffing in place. And this is something you would never see here. I mean, look at the timeline here. Hurricane watch was issued Sunday at noon. 6 hours later, it was upgraded to a warning. And again, keep in mind, Bob made landfall Monday at 2 p.m. Here, a watch is being issued 26 hours in advance, and a warning even less than that. So you just don't see that today, and it just kind of makes you realize how much forecasting has come, especially hurricane forecasting. Now, there was severe weather the day before Sunday, so there was kind of competing resources. They really had their hands full here, the Weather Service, that weekend, dealing with severe weather the day before a Hurricane Bob. So just to give you a little perspective of what was taking place. And we'll look at some of the forecast discussions too. And here on the top left, this is 2:15 on Friday afternoon. And you can see most of the discussion is talking about the severe weather. And back then, these forecast discussions had many more abbreviations than today, because forecast discussions back in 1991, there was no internet. So these were pretty much an internal product. But you could see there was just one little, I think, sentence here. You have midway, it says, meanwhile, moisture from Tropical Storm Bob makes inroads to the south coast by 48 hours on both the NGM, which has been decommissioned, and the AVN model, which has transitioned to the GFS model. But again, this is 2:15 on a Friday, and there's one sentence dedicated to Bob. And for example, tomorrow, Friday, I'm sure we'll have a lot more discussion in the forecast discussion with Henri possibly making landfall Sunday. So just to put it in perspective, and even the same thing with the discussion in the lower right here. That's just the last sentence there. Looks like Tropical Storm Bob will likely brush Hatteras and then move out to sea, but it's too early to tell right now. So really, not much lead time. Again, this is Friday, and Bob makes landfall on Monday. And the next slides also show you some forecast discussions too. Let's see here, the one on the left, and this was Bob Thompson's, our former MIC, discussing this here. And the last paragraph there on the left there continues to be indications that Tropical Storm Bob will deepen further to at least a minimal hurricane. Bob is now in our pre-watch area, pre-checklist. All officials and should recheck staffing. So you can see Bob is actually now starting to get a little bit concerned. I could just tell by reading his discussion. And that's Saturday morning at 10 a.m. on the left. And then on the right is the Saturday afternoon discussion. And you could see things are starting to ramp up a little bit. And I think on the next one, Bob, I think, really nails it here. So this is Sunday morning. And if you look at the last paragraph down at the bottom, so Bradley and Providence, please keep Connecticut and Rhode Island emergency management informed on the latest developments with Hurricane Bob. Still looks like a potential landfall for southern New England Monday evening, and perhaps a Category 2 strength. So Bob Thompson was on to this here, and it did make landfall at Category 2 hurricane. But again, this is 11 a.m. on Sunday, just 24 hours ahead of the system. And Bob continues, in the afternoon here to that last paragraph, really urging preparations continue, showing signs of strengthening. Have to watch the timing as the hurricane could accelerate significantly north of Hatteras. Also have to watch the interaction with the amplifying trough to the west. We'll try to stay in touch. And like this last sentence, keep Bradley to remain open tonight, and Worcester may need extended hours. So try to firm up contingency staffing for Monday. And so really, you could see they're really scrambling and trying to react here to this hurricane that's right on the doorstep, less than 24 hours away. All right, so Hurricane Bob's response Friday, there was a heads up to emergency managers. There was some internal preparation actions Friday afternoon. You can see there's nothing that took place on Saturday, and it's probably because they were preparing for the severe weather that occurred on Sunday. But this, what took place here on Sunday is really kind of hard to comprehend. Sunday evening, MEMA and FEMA regional directors were contacted on home Sunday evening, basically 12 hours before landfall. So that's something you just don't see today, but it just goes to show you how much progress we've made in weather forecasting, and especially hurricane forecasting. And the EOC, the Operations Center in Falmouth, opened up 7 p.m. Sunday evening. So, I mean, 18 hours before landfall. It's just amazing. And most EC's operational centers were activated Monday morning, just hours before landfall. And there was even a moderate amount of traffic headed into Boston. So people were still commuting into Boston. It was kind of like a lot of people didn't really know what was going on. And maybe some of it had to do with Russia was breaking headlines there. There was some news going on in Russia, but really interesting how things unfolded. All right, well, then and now. So back in 1991, it was pretty much more business as usual than you would expect today. The storm was not really anticipated until it formed. Heads up by National Weather Service via phone calls. I mean, think back 1991, we didn't even have the internet, so phone was our only communication. And even the Doppler radar, we just had the prototype Doppler. Our Doppler radar in Taunton, Northern Mass, wasn't installed in operation until 93, 94. And that was the case pretty much across the Northeast. It wasn't until 1993 or 94 that the Doppler was operational. So it was still 2 years prior to the Doppler. Now, compared to what's happening today with Henri, I mean, we've been sending out emails now for, I think, a few days already, and landfall isn't expected until Sunday. So 5 to 7 days in advance, we start with our impact decision support services issuing emails to emergency managers, to the states, cities. In our video briefings, I think today we started for the first time video briefings. So just it's amazing the amount of information that we're pushing out today compared to back then. And then the platforms are so different, you know, social media platforms, and even think of cable news, how many cable channels we have for dissemination. And also the tools, I mean, the science, the technology, the Doppler radar. We have dual pole now, rapid scanning. The satellite technology is just amazing. 1-minute scans, high resolution models that Joe was showing you earlier with the convection ensembles. And we have so many more observations than compared to back to 1991. So it's amazing how much things have changed in the past 30 years. And yeah, so that's that segment on Hurricane Bob. I'm not sure if you want to take questions now, Joe, or wait to...
Yeah, we can do that. And I probably should have paused for questions after my section, so we'll do both at the same time. So let's see. John wanted to know if the storms typically arrive earlier than the model guidance indicates. Do you folks correct for that in your forecast, the hour-by-hour chart? Yeah, actually, John, we do. We can, take the model output and kind of adjust the timing by, maybe move it up 2 or 3 hours to adjust for that. So yes, we do. Hopefully we do, Frank. Not just go with what the guidance says. But yes. Yeah, we can certainly do that. And John also wants to know, in the sounding that I showed, look like there are 2 spots of drier air. These layers of dry air have any impact on the storm? No, I mean, in some cases you want some dry air because it helps with evaporational cooling and things like that, and getting your downdraft stronger. So as long as it's not a very deep dry layer, John, it really doesn't impact that at all. So let's see, Ron joined us late, wants to know if we're giving an update on Henri. Yes, we are. So stay tuned for that. Let's see. Oh, Eleanor's on tonight. Eleanor, I don't know if we can unmute you. So Eleanor was formerly of our office. She retired a year ago, and she was in Portland. Yeah, you know what, Eleanor? Let me see if I can unmute your mic, and you can just say a few words. And always good to hear from you. So hang on. Okay, let's see. You should be good to go, Eleanor. Go right ahead.
Hello, can you hear me?
Yes, we got you, Eleanor. How are you?
Fabulous. Hi, guys. How you doing?
Hi, Eleanor. Great to hear from you.
Hi. Yeah, good talking to you guys. I just wanted to give you a little perspective. I was stationed up at the Portland Jetport in Maine during Hurricane Bob. And that storm, once it went by the Mass coast, it headed right straight for Portland. However, it stalled over Portland Harbor. So we got a deluge of rain out of that. Matter of fact, set a record for all rainfall up there at 7.75 inches on the 19th of August of 91. That record was then broken 3 or 4 years later. It was after I left there, but they had another storm that came up and gave even more rain. But no, that storm was pretty amazing. It just sat there for several hours and dumped rain on Portland. Then it took a right-hand turn, followed the coast up to about the Bangor area, the central Maine coast, and then it came in and went right over Bangor later on that day. So it was a very interesting storm, to say the least. It was windy too. I think it was downgraded to a tropical storm by then. Does that sound right, Joe?
I think so, yeah, at that point.
Yeah. So, I remember the winds. They did have some strong winds, but not a lot. But they did have several rivers go over, including the Presumpscot River, which is in just to the west of Portland. So they had quite a bit of flooding up there too. But it was a pretty nasty storm up there.
All right. Great. Thanks, Eleanor. Appreciate the insight. Got to have some, that's true. You were up there and
Yep.
experienced Bob.
And we transferred back down the next year.
There you go.
Next 2 years, because we got married up there the year after. We're celebrating my husband Dean and I are celebrating our 29th anniversary next month. And so it was like 1 year after. And then in 93, we moved back down to, when you were still in Boston, then we moved to Taunton.
Right. And we haven't had a landfalling since. So there you go. It was,
I know.
We can credit you with protecting us all those years.
Oh yeah, right.
Great.
Okay, Joe.
Eleanor,
I don't know how much more you can sell on that.
No, great to hear from you. I hope you're doing well, and we certainly miss you at the box. So best to you and Dean, and happy anniversary too.
Hopefully we'll see each other next month.
Absolutely. Looking forward to it.
I'm sorry, October. I keep thinking this is September. It's not. October.
Almost. Cool.
All right, we're getting there. Yeah.
All right, take care.
All right, I'll go back to mute.
Okay, sounds good.
Take care, Eleanor.
All right. So let me go through a few more. We've got a lot of comments, just which I really appreciate. I know we want to get to the briefing. So let's see. So Jeffrey wants to know what type of computers we use in forecasting models. Frank, I might need help with this one. I know we have the bunch of supercomputers.
Yeah, I mean, that's all I could think of. Yeah, the supercomputers down in Washington. IBM, I think, is a big contractor for us.
Yeah, and I mean, they just recently upgraded the whole suite of what they use to run the various models. So might be worth a Google search there to find out exactly what it is, because I don't remember off the top of my head. So let's see. All right, that looks like it for the questions. So what we can do is, why don't we